Hi everyone. First of all, good luck on your exam tomorrow. We only had one request for the Homework 5 / Exam 1 Review problem solving request forum. So it was posted to do problem 6 from the exam review, and so I've already pulled that up on WebWork over here. And I'm just going to go ahead and work through it. Let me see if I can zoom this in so you see it a bit better. Zoom. There, that's a bit bigger. Okay, cool. So we're trying to solve the problem y prime is equal to y times y minus 1. And this is a separable equation. They tell us that in the web work, but on the exam you need to be able to recognize when something's separable or linear so you know the best way to solve it. So the way I know this is separable is because I see y times y, so I know it's not linear, and I can kind of group all the things that depend on y and all the things that don't. I could move them to the different sides of the equation so it looks like it's separable. For those separable equations, I like to write dy dx for our derivative, and then we just go and move the y's to the left and the x's to the right. And it's like that. And then we're going to have to integrate this, and we did this in class on Thursday, and I talked through very slowly how the integral on the left side works. I'm going to try to go a little bit quicker here, just because you have limited hours before the exam, and partial fraction decomposition is not something you need to know. But the idea is that when I look at this, I don't know how to solve it. Even if I multiply it out, I've got a y squared down there and no y up top that I could cancel out with u sub. So my best bet is going to be to take advantage of the fact that I know how adding fractions works. If I got to this point of having y times y minus 1 in the denominator, that could have happened if I had something over y and added it to something over y minus 1. Because the way I would do that addition is I would cross multiply and add together with the product in the denominator. So I'd have a times y minus 1 plus b times y all over y times y minus 1 is how I would do this addition. Think about if you were trying to do a half plus a third, the way you would add those two fractions together, but now we just have functions instead. So if that's going to be equal to 1 over y times y minus 1, the bottoms match. So if I set the numerators equal, I can try to solve for the a and b that make this true, and then I can decompose the fraction I don't know how to integrate into the sum of two fractions that I do know how to integrate. So I would like to solve that equation. I have two unknowns, a and b, and only one equation, which is kind of difficult for me because I'm always told that I need two equations, two unknowns. So the way we turn this into something we can solve is we note that y can be any value. So this has to be true no matter what value y you plug in, whether it's y equals 0, 1, so on and so forth. So if I group like terms in y, and note that the left side doesn't have any y, then I need to make this thing that has a y equal to 0, and then this other thing that doesn't have a y equal to the number I had to start. The reason I do that is because, sort of ignoring that part for just a second, if I try to solve this equation for a specific y, and get an a, b, and a value, as soon as I change the value y, I would get different a and b that make it true, or it wouldn't work anymore with the a and b I already solved. So the only way to make this true for every y is to make sure that the thing that multiplies y is equal to 0, so it just goes away. so that's why I'm going to solve it this way. It's going to give me the system of equations that the a plus b has to be equal 0, and the minus a is equal to everything else. So in that case, I know that a has to be minus 1, and if a plus b is 0, that makes b 1. So (1 over y times y minus 1), I think, is the same as minus 1 over y plus 1 over y minus 1. Which honestly doesn't... Yeah, there we go. So that checks out. I did my algebra right. I just wanted to check before I integrated, because otherwise we would get like 5 minutes down the line and I try to put it in the web work and it's wrong. So the whole reason I did that was so that I could rewrite my integral. I'll do the whole thing first. Like this. Now I've gotten rid of the odd product that I didn't know how to integrate. Now it's just two like natural log integrals. So I can always like separate out sums of integrals like that. And so that's what I get when I take my integrals. Integral of 1 over x is natural log. You could do a u sub here if you weren't happy jumping right to that's natural log of what's inside. But because y isn't modified in the denominator, it doesn't change integrating in natural log at all. And then the right side, I could have integrated at any point, but I waited until now, and I did it wrong. The integral of dx with respect to x is... No, I did it right. Is x. Yeah, that's the integral of 1. We're good. And then I added a constant. If you added a constant on the left side as well, that's fine. Just make sure you combine them before you start solving for c based on your initial conditions. And so if this was an exam, you could go ahead and say like, this is my implicit solution, and you would be fine. But because this is web work, it needs to get your answer in a specific way, so it asks us to manipulate it to do that. So I'm going to copy this and move it to the next slide. But kind of this fussy algebra we're about to do isn't super super critical for your studying. So also if you want to just move on to something else, now would be the time to do that. Okay. Okay, so I need to get this where c is by itself, and then I have an e to minus x. So to get that e, I know I'm going to have to be getting rid of my natural log. So I'm going to go ahead and make that happen first. So you can combine sums of natural logs, move multiplying constants inside as powers, or divide differences of natural logs. So that's what I've done here. And then I take both sides inside an exponential to cancel out the natural log on the left. Remember, when you take e of a sum of things, the sum stays inside the e and it becomes multiplication afterwards. I'm still seeing a lot of people who do this like equal e to x plus e to c, and that will lead you down wrong paths. This C is changed now. I could mark it with a tilde, but I'm not going to do that, and you don't have to either. This is starting to look right. I've got an E, but it's supposed to be a minus X. So you can think about dividing that E to X through, or multiplying by E to minus X to cancel it out on both sides. Either is the same. Kind of the same as if you had a 2, you can divide by 2 or multiply by a half. Either way, I get to the point of having this. Remember, divide by E to X means multiply by E to minus X. And then that E to minus X needs to be by itself, but I can note that this fraction is the same as y over y minus 1 over y. Whenever you have a sum in the numerator, you can split the fraction, but if you had something in the denominator, you're not allowed to break them apart like that. So this is E to minus X times 1 minus 1 over y, or E to minus X minus E to minus X 1 over y equals C. So I've got E to minus X, and I've got my equals C, and I just have to plug in my H. So for me, that's minus E to minus X divided by Y. Cool, I got it right. So then I can move on to the next part, which is finding an explicit solution given y of 0 equals minus 2. So I'm going to go ahead and go to a new page. So we just have to solve for C and then isolate y, that's the explicit solution part, and solve for C is the initial value problem part. So my initial condition is y of 0 equals 2. That's x equals 0, y equals 2. So I plug that in and solve for C. I've got e to minus 0 minus e to minus 0, 1 over 2 equals C. E to 0 is 1. So I've got 1 minus 1 half equals C, or C is a half. Then I plug in that C back to my equation, and I try to solve for y. My best bet for that I'm going to move the y term over, and then you can think about divide by e to minus x or multiply by e to x. Get rid of that x on the right. I want y by itself. Then it looks like that. And I'm going to have to like divide by everything to get y by itself. So for me, I want to combine what's on the left into like a single fraction first. So I've got 2 over 2 minus a half e to x. So that's just 2 minus e to x over 2. So I just added those two things together and made it one fraction. And then you could think like I multiply y over, and then I divide by this to get y by itself and not divided by. Oops. So I think my answer is going to be y is 2 over 2 minus e to x. And I'm going to plug that into WebWork, and if it's wrong, we will check my work. It's wrong. Okay, let's see what went wrong. So I wrote down y of 0 equals 2. It's actually y of 0 equals minus 2. Some of you all might have noticed from class, whenever I sit down to help you all with a question, the first thing I do is ask to see the question to make sure you wrote it down wrong. It's because this happens to all of us all the time. So the process is fine. Real quick, I'm just going to fix everything that happened. Actually, it's going to be 1 there still. It's here. It becomes the 3. You know, I'm going to stop erasing it. I'm just going to write the 3 over it because that makes me real slow. So it just became 2 minus 3 to x. Let's see if that fixes it. Yes. Okay. So it was just that I wrote down the wrong initial condition to start. But the process was fine. So I would say just go with the problem that I chose to solve, and this was the right answer as you had before. But I just had to do a quick fix for that woodwork issue. So nobody ever came in, so there are no questions, and I'm just refreshing the forum real quick to see if there were any last-minute posts. Unfortunately, WebWork doesn't let me refresh. It makes me re-navigate to the forum every time. I don't know why. Sorry, Blackboard, not WebWork. I don't know why Blackboard chooses to be that way. And it looks like there was nothing new. So I will go ahead and stop the video here and get it posted for anyone who needed to see this problem.